Hi, this is Chris Evans for Gestalt IT. I'm here with Steve Fingerhut from Pliops. Steve, good to see you. Would you like to introduce yourself to everybody?
Sure. So I'm Steve Fingerhut. I am President and Chief Business Officer for Pliops, which is an Israel-based company. We're backed by Intel, NVIDIA, Xilinx, SoftBank, WD, a few others. And we're focused on accelerating the most challenging workloads around basically all the applications that store data to flash today and going forward, and making those as efficient and scalable as possible.
Okay, so you talked about the idea of acceleration there. Could you give us a bit of background just on the problems that you've seen in the enterprise over the last few years, and why a technology like acceleration is really important?
We've all heard about the incredible data growth, right? The zettabytes being created and the challenges that creates. And of course, you don't want to just store the data, you want to access that data and do get insights, transact with your customers, et cetera. And that is becoming increasingly challenging. So we hear from a lot of customers that as that data grows, the number one thing is how do you keep up with the capacity growth and do that efficiently? And then, of course, you want to access that well. So how do you continue to access it in a very high performance way? And then, of course, as you scale these massive data sets, everybody has reliability built into their infrastructure, to their applications, but drive failures or SSD failures are still a big impact on the infrastructure, will impact the efficiency and lower the performance overall. So we're delivering those high performance, large capacity applications in a reliable way is also a key challenge.
Okay, so when we dig into your technology in a bit more detail, which we'll touch on the specifics of the product in a second, why are we looking at the idea of offloading this acceleration? Why wouldn't we do it with the cores that are sitting in our general CPUs and general purpose compute engines? Because we have many cores there now. Why putting in new hardware? Why does that make more sense than just using the cores that are already there present?
That's certainly the way that everyone's doing it today. And the challenge is you have very fast media. The storage media and SSDs, they're easily 1,000 times faster than hard drives were. And obviously hard drives were the predominant storage media just a few years ago. You have even faster media coming out like Optane, and even low-cost media like QLC is extremely fast relative to hard drives. So you add that into a system, and the processor is not 1,000 times faster. So the application architects, like the database, the software-defined storage, analytics architects need to basically cut corners. So they will compress data less efficiently. They will pack it less efficiently. They'll use inefficient reliability mechanisms like RAID 10, or maybe just say, forget it, we'll use software only. All those come with a very high price. And you probably heard about Moore's Law. It's kind of another common theme. Moore's Law is slowing. You can add more cores, that adds cost. You share the buses, the memory and the IO buses with all those other cores, so you get diminishing returns. So it really is, if you think about the data growth that we've already experienced, there's even more coming, and everybody wants to store that data on the fastest media possible. So this problem is difficult today. It's getting more challenging, and customers are looking for a way to solve these problems with a specialized device that enables breakthrough types of performance.
Okay, so why don't you tell us about your technology, your solution, and then we can dig into that in a bit more detail.
Sure. So what Pliops has developed is a processor that we deliver in the form of a low profile, right, half height, half length PCIe card, fits in any standard server, works with any SSD. We're not selling the flash. You can work with all of your current flash suppliers, but it has a very high performance, what's called a key value store or storage engine. That's really the core technology. So the easiest way to work with that, or the most direct way, is actually to directly through a native key value API. Things like RocksDB are out there, and this is really for the application developers themselves. So just about every application that runs on Flash has this function, whether it's called RocksDB or something else. we've built RocksDB is a state-of-the-art version created by Facebook, built off of Google technology. It's the best you can do in software, but it will take up about half the cores in the system, and it amplifies the data read and written to your SSD by several orders of magnitude. Writes can be amplified by up to 50 times, reads up to 100 times, and that's the best you can do in software. What we've done is implement that same capability. It's a different architecture, but using a dedicated processor that delivers the equivalent of hundreds of Xeon Gold cores of that function. So you can basically remove it from your system, rely on Pliops to deliver that capability, and you're going to get extremely high performance. We bring those read, write, and space amplification levels to their theoretical minimums, and you get a extremely efficient, fast, scalable device that uses the lowest cost media available at a very fast way. And then we also have a mode that is very popular now, which is a block interface. So we present a block interface. We actually convert blocks to key value pairs, but what that means is you can run our device with no changes to your application. We will look like just any other SSD in your system and perform all these great performance, reliability, and capacity expansion features.
Okay, I guess what you're saying there is that to a certain degree, you're correcting some of the challenges, some of the issues with the underlying media. So, you know, we know things like QLC has a lower endurance than, say, some of the other media that we've seen over the years. And that amplification challenge is very difficult to fix unless you do it in the device. And those are the sort of things that you're fixing. I just want to just qualify, you know, the two different modes you said there. There's both the ability to expose a block device, but also you work natively within databases, and that's the RocksDB side of things, isn't it? The key value store.
Exactly. And we've already worked with several software vendors. We're public with Redis Labs, and they have a version of their Redis, which is a very popular in-memory data service that uses Flash, called Redis on Flash. They use RocksDB to persist data to Flash. And it was about a 2-hour operation for one of our developers to change it from software to our device. And then we actually perform about 10 times faster than Flash in that use case, and it delivers DRAM-like performance. So that's just an example of the capability and the promise of what that can offer when you do that little bit of work to move things over. You mentioned QLC as well, and yeah, it's a challenge that basically anything to do with writes, you have limited write performance of a QLC, as well as the endurance, right? That SSDs is probably, everybody listening knows they have a limited, as you know, it's like a tire. When you use it, when you write to it, it wears out. And QLC has much lower endurance than TLC, but it comes with that great low cost. So we know how to write to QLC, so it lasts a very long time. First, we eliminate about 90% of the writes going to the flash to begin with, and then we write in nice sequential operations that make it very friendly for that type of flash. So we can perform, our product performs the same whether it's QLC or TLC based.
Okay, so for customers then, is this typically going to be a cost saving, an acceleration saving, an optimization saving, a combination of all of those things together?
It's a combination of all of them. We'll have performance, and we see scaling from 3 to 15x on performance, capacity expansion, a combination of the compression, moving from things like RAID 10 to a very efficient RAID 5-like technologies. You can get about 6 times more user data on your flash versus if you're not using Pliops. And then reliability, I mentioned that we call drive failure protection. There's really no trade-off. The performance is twice that of RAID 0, even during a rebuild. So it's really, you get all your capacity, you get all your performance and more, plus drive failure protection. So you really, you get it with no compromises.
And would a customer just typically drop this device into their server and reconfigure, or do they have to do more work to make it actually work, for example, with the database technology? Is there some additional code that they would have to add, for example?
In the block mode, there's no changes, right? Like you described, put it into your server, put it into your storage node, and it will accelerate and bring all those values, performance, reliability, and efficiency to those nodes. And then if you want to take full advantage, I call it the turbo mode, then there's a little bit of work to take your database and move it to the native key value. And then from there, really, it's no maintenance going forward.
And where are you seeing the adoption of this? Are you seeing this in typical enterprise? Is it good for hyperscalers? What sort of companies are looking to use the technology?
We've been focused primarily on the largest cloud and web service providers, just given their extreme focus on infrastructure efficiency, and we're expanding into the enterprise. We do have several Fortune 500 customers, and we're expanding into that more as we go into the second half of 2021.
What can we expect from the future then? How's this technology going to go forward? I guess you can adapt it for other features other than what you've done today. It sounds to me like it's relatively scalable, relatively customizable.
Absolutely, yeah. You're going to see higher performance in future releases, more capabilities, more storage capabilities. Really what we're doing is taking the most challenging and valuable features of an all-flash array and bringing those into a very efficient building block that can be used in all systems. So we definitely see the world moving to cloud type architectures, distributed storage, distributed databases. We can be that building block that brings the reliability, performance, capacity expansion, and manageability from a much smaller footprint in the data center.
One last thing as we wrap up, Steve, I'd be interested to understand how your technology has affected the landscape in the last 12 months. We've obviously had the coronavirus, the COVID challenges, but also now we're seeing semiconductor shortages, and that may well put challenges on people to optimize the technology they already have on the data center floor.
Absolutely, yeah. Talking to customers, and they're comparing this to the Thailand floods of several years ago that caused the hard drive shortages. And they're saying in many ways it's even worse because it is across all components impacting the data center. So we're seeing a very sharp uptick in interest to get more out of existing architectures. And so it's how do you do more with the same or even less? And I think more and more, the way customers look to GPUs to accelerate their machine learning workloads, they will be looking to Pliops and similar technologies to scale performance, get more out of their storage without having to count on more and more tractor trailers arriving with more and more servers and storage. So definitely, and it's unfortunate. We expect this will end sometime, but we've heard forecasts of this even lasting into 2023. So we expect this to be the new norm for several more years.
Great. Where can people find out more, Steve?
Yeah, please come to pliops.com. Easy to find out more information, get a hold of us, and we're very happy to talk with you and see if we have if there's a fit. We also have some TCO calculators. You can see what type of savings you can get given your particular environment, and then let us know, and we'll be happy to engage more.
Great, Steve. As always, great to catch up with you, and look forward to catching up with you soon.
Absolutely. Thanks a lot, Chris, and thanks everybody for listening.